Morning everyone, it's Amir sir again here in front of you with the 7th lecture. Hope you people have done the homework which I have given in last lecture. Today we are going to start with the new topic of solid state, that is the closed packed structure. So we have already known that in any cubic crystal the atoms are arranged at their lattice point in spherical shape. So why spherical shape? So we are going to get the answer of that all. So closed packed structure for identical solid sphere. So we know that any shape have some direction, three dimensional, that is 3D, 2D, 1D. So based on that, the classification of solid has been packing has been done here. So solid which have non-directional bonding, their structure is determined on the basis of their geometrical consideration. So here it is said that those solid which have non-directional bonding, their structure is determined by geometrical consideration. It is found that lowest energy structure is that which leaves minimum vacant space. For example, if I tell you that you have to pack maximum number of goods in a cartoon. For example, you have given a cartoon and you are said to fill in this cartoon maximum number of goods, the things which I will give you. First thing, I give you the triangles. Second thing, I will give you rectangle, and third thing, that in the form of goods I will give you a sphere. So which one will have maximum filling in that cartoon? So maximum filling will be done for sphere, because sphere is non-directional, while triangle have three cones, rectangles have four cones. So therefore different structures have different types of cones. So but in spheres there is no any definite cone, and that is non-directional, and which occupies least space and leaves minimum vacant space. So therefore it is said here, it is found that the lowest energy structure is that which leaves minimum vacant space, a structure in which each particle is surrounded by greatest number of possible neighbors. So that shape will be spherical in shape, which have least energy, which have maximum stability, which occupies least space and leaves minimum vacant space. So these are the properties. Therefore we consider that the position at unit cell in a sphere is occupied by solid spheres. Now proceeding further, for it, consider particles as hard sphere. So we have to consider in any type of crystal the particles as hard sphere of equal size, which are arranged in 3 dimensions. To occupy maximum available space, the hard sphere should be arranged, will be economical, is in close packing. So therefore in any type of close packed structure, it should be economical also, it should occupy minimum space also. So therefore it is in hard spherical forms. Now we are going to know that how the particles are arranged. Different particles are arranged in equal size in cubic crystal. So there is 3 ways on the basis of which particles are arranged in cubic crystal. So the first way is close packing in one dimension. Close packing in one dimension means in lengthwise or breadthwise. Either the particles are arranged in lengthwise or they are arranged breadthwise. So close packing in one direction means what? Only in one way. Each sphere is in contact with 2 of its neighbors. So let's see how is it. So we have example here in front of you for one dimension. Suppose 4 spheres are here, and the sphere which is darkened is in middle. So it is surrounded by how many spheres? It is surrounded by both sides with 1, and this side 2. So number of sphere which neighboring spheres which surrounds the middle one is 2. So therefore coordination number is 2 for this one, and it is present only in lengthwise. Therefore it is called one dimension. So therefore we see here close packing in one dimension, that only in one way particles are arranged, spheres are arranged, and the coordination number is 2 here. Now we are going to see close packing in 2 dimension. 2 dimension means lengthwise also will arrange the sphere, breadthwise also will arrange the sphere, like this, which you can see in the figure also. Lengthwise, one row is arranged on the first row, second row is there, third row is there, fourth row is there. So it is arranged lengthwise also and breadthwise also. So close packing in 2 dimension, what is it? Let's see. Two-dimensional close-packed structure can be generated by stacking or placing the row of close-packed sphere. This can be done in 2 different ways. So this can be done in 2 different ways, that is square close packing and hexagonal close packing. So what is square close packing? Let's see. Suppose I have drawn this sphere for you, that if the first, that is the first row, the spheres are arranged horizontally lengthwise, then above it another sphere is arranged, then again another sphere is arranged breadthwise. So lengthwise as well as breadthwise, so it gives 2 dimension here. Now consider this one, this sphere which I have darkened. So the sphere which is darkened is surrounded by how many spheres? So you will find out that it is surrounded by, or it is in touch with 4 spheres. 1, 2, 3 and 4. So what will be the coordination number? In square close packing, the coordination number will be 4, and the type of packing which we have obtained by stacking the one sphere above the other will get a packing called square close packing. Because if you just consider the single sphere, you will find out that is in contact with the 4 spheres from 4 sides. So what will get? You will draw the radius, a line to their radius. What will get? Will get a square here, a square here. So therefore it is called square close packing, having coordination number 4. As the arrangement is same, as the arrangement above is same, the same type of arrangement is below, means the sphere just below the above sphere is the another sphere in the second row. So therefore the arrangement obtained, if I mark it as A, the second arrangement is also similar to first one, that is also called A, the third one is also called A, the fourth one is also called A. So the arrangement, the pattern is called AA type pattern. Now I am going to read whatever I have explained you. So here the square packing, the square close packing is the center of a sphere lies one below another, second row may be placed in contact with first row, which I have explained you. The sphere of second row aligned horizontally as well as vertically. So sphere is arranged horizontally also, vertically also. Vertically, if first row is A type row, the second row is exactly as first one. So A type row, it is also A type row. That one is also A type row. Therefore arrangement obtained is AA type as shown in figure, which I have already shown you. Which type of arrangement was there? They are arranged AA in AA type pattern all. Therefore the pattern is AA type pattern. The arrangement is AA type pattern. Each sphere is in contact with 4 of its neighboring sphere. Thus 2-dimensional, what will be the coordination number? In square close packing, the coordination number will be 4. It is 4 here, and packing is called square close packing in 2 dimension. That is called square close packing in 2 dimension. So we have seen the coordination number in 1 dimension was 2, and in square close packing 2 dimension the coordination number is 4. Now in this case 52.4% of volume is occupied. So how much space is occupied in square close packing by the atoms? So it is calculated that the space occupied is 52.4% of volume, and the remaining 47.6%, subtracting from 100, 52.4 will get 47.6% is empty, and that empty space is called what? It is called void, or the vacant space. The vacant space which is left in cubic crystal after occupying by the solid sphere, the space left is called void, vacant space. So this way we have learned square close packing in 2 dimensions. So 3 things you have to keep in mind here. First thing, how the square close packing is formed in 2 dimension by placing the sphere horizontally and vertically, we get coordination number 4. Which type of pattern is here? So it is AAA type pattern. How many space is occupied? 52.4% of the volume is occupied. How much space got vacant, that is called void, is 47.6%.